Look at problem B. In problem B, I noticed something I really don't like, and I know most students won't, is we've got an equation here that has a lot of fractions. So let's clear the fractions before we do anything. So we've got 1/2 x minus 1/4 y equals 1/2. So to clear all these fractions in one fell swoop on this equation here that we've got, and I'm going to label this as my first equation, because most likely that's what I'm going to use. We'll have to see though. Is to get rid of the fractions, I need to multiply everything straight on through on both sides by a 4. So let's see how that helps me though. So in my first piece, what happens is I get a 4 divided by 2, which is just a 2. You still have the x there. On the second one, you get a 4 divided by a 4, which is a 1. Don't forget there was a minus sign out in front of this. And we do have a y still. Equals, and on the last piece on the other side, we got 4 times 1, which is 4. Divided by 2 is just a 2. Now, looking at this equation, this one we'll do is I want to get the y by itself. That's what's going to be easiest. If I'm doing substitution, I need to get a variable by itself, so we're going to work on getting y by itself. So right now we've got the equation 2x minus y equals 2, and we're going to try and get that y by itself. So the question is, how are we going to do that? So what we'll do to get y by itself, first of all, is we'll subtract 2x from both sides. So what that does is that gets us a negative 2x and a positive 2 on the right-hand side. Be careful. On the left-hand side, we still have a negative in front of our y. So this is a negative y. So I still need to get rid of the negative sign out in front of that y. Well, remember, if I have a negative sign out in front, it means I actually have a negative 1 in front of my y. So how do I get rid of that negative 1 in front of my y? I'm going to divide everything on both sides through by a negative 1. And let's see how that helps me. That gets me a y equals, well, let's see, first of all, the negative 2 has to get divided by a negative 1, which will turn you into a positive 2x. Then second of all, we have to divide the positive 2 by the negative 1, which will turn it into a negative 2. And then we'll do exactly what we did before, which is now we have something that we can replace y's with. Where are we going to replace the y's with this? Into the equation we haven't used yet. Well, the only one we haven't used is the one that's unlabeled, that top equation, which was the negative 2x plus 5y equals 22. And remember, what we're going to do is we're going to use our first equation, the fact that we have y equals, and make a replacement here. So we've got negative 2x plus 5, and then our y will get replaced with what we found, which is that 2x minus 2. So we'll replace that y with 2x minus 2. Again, just like the last one, don't forget when you plug something in, you need to put parentheses around it, which then gives us that we get 22 on the other side that hasn't been touched. So the question is, what do we need to do next? The next thing that we need to conquer is getting rid of those parentheses, which means I need to distribute the positive 5 to everything inside first. That negative 2x that's out in front will stay the same, but distributing the 5 will get us a positive 10x and a negative 10, and we still have our 22 on the other side. So the next thing that we can do is combine our like terms. Our like terms are a negative 2x and a positive 10x. They are on the same side, so we just add them normally, which would become a positive 8x. We still have our minus 10 on the left and our 22 on the right. Keep on going. So getting the x by itself will add 10 to both sides, which will get us, let's see, 8x on the left-hand side and 32 on the other side. Keep on going. Last step we'll do is divide both sides by 8. And that gets us that x equals 4. However, we are not done. Remember, our answer, if we're getting a actual value, means that our answer should actually be a point. We just only found our x value. Our x value was a 4. So remember, x's go first in your point, so let's plug that in. But now I still need to find my y. So I'm going to take my 4 I just came up with and plug it into my first step. You can technically plug it in anywhere to each line. It doesn't matter. It's just this is the easiest. So we'll replace the x with a 4. So we'll have 2 times 4 minus 2. Well, 2 times 4 is 8. Minus our 2 will get us 6. So our y value is 6. So that's what we're going to plug in as our y. So our final answer is the point 4, 6, and we're done with that one. Let's try another one. Let's take a look at C. Notice C is actually perfectly set up for substitution. The reason being is if you look at that first equation, is the x is already by itself. So that's what we're going to do. We're going to use that equation, that first equation, and leave it as is. I don't need to do anything to it. But if I'm going to do that, then I still have to plug it into my second equation. So I'm going to take my second equation, the 3x minus 9y equals 0. And what this first equation says is I can replace x's with 3y. So I'm going to replace any x's with according to this, 3y. So I'm going to replace the x with a 3y. Again, don't forget your parentheses. Anything else in your equation, though, is going to stay the same. So now, order of operations is going to tell me to go